Welcome. Those who don't know me, I'm Eric, the Dean of the School of Information. It's my pleasure to welcome you this afternoon. I'm really looking forward to this. I don't feel like I know our Dr. all this because I've only been here 6 months, so I'm really looking forward to hearing more about the work that's going on here. Hopefully you're excited as well. This is obviously a great school and a great university, and I think one of the things that really makes any university like this stand out is the work of our doctoral students, because they're the next generation that's going to be carrying our field forward. So hopefully we're going to hear a lot of interesting talks this afternoon that will be right at the forefront of thinking about the topics that are near and dear to our hearts for the School of Information. So I don't want to take up a lot of time because you're not here to hear me, or you're here to hear the talks this afternoon. So let me go ahead and turn over immediately to Satej, who's going to be giving the first talk.
Thanks. All right, there we go. Thanks, Dean Meyer. My name is Satej Soman. I'm a fourth-year Ph.D. student here at the high school. I'm advised by Josh Blumenstock, and today I'll be talking about how to use remote sensing or Earth observation data with machine learning to track changes in economic indicators. I'll give a little bit of an overview about how Earth observation data has become more available in the past few decades, talk about some of the applications to social science that this has unlocked, and then finish with some of my own work that focuses on translating these new types of measurements into actual decision-making and policy-making on the ground. So I hope by the end of it, you understand why I get pretty excited about pictures of Earth that are not too dissimilar in principle to this one. I don't know if anyone recognizes this particular image. I think I've told a couple of you, so you're not allowed to answer. But anyway, this is a pretty famous image known as Earthrise. It was taken by an astronaut on the Apollo 8 mission in 1968. And while it's technically not a satellite image in the way we think about satellite imagery today, and it's not even the first image of Earth taken from space, I think it's a useful anchor to think about how society in general has interacted with Earth observation, because it was one of the first widely disseminated images of Earth from space. So hours after the Apollo 8 mission landed back on Earth, NASA had a special team that took the film canister for this image, had it processed, and then sent it out to the Associated Press, and they syndicated it nationally. So this image was the first time that many people realized that the environment that we inhabit can be monitored, observed, and perceived from space. So in the intervening decades since, there was basically a government monopoly on the satellite imaging infrastructure that took more granular and high resolution pictures of the Earth from space. But despite that, there were a number of commercial and research partnerships with agencies such as NASA and the US Geological Service that allowed non-governmental organizations to use satellite imagery for a number of tasks. Despite this, the demand for more granular, more up-to-date images that responded to the needs of specific applications outpaced what the government was able to supply. So about 30 years after Earthrise, IKONOS, the first commercial imaging satellite, went into orbit. Now, this is one of the first images that was made available from IKONOS. It kind of looks like a hand-drawn map on a CRT television. It's a flyover of the National Mall in Washington, D.C. But in order to access even this, it costs, I haven't been able to get a full quote, but I've been told there are a lot of zeros and a couple of commas. But since then, this was another turning point, because since then, the floodgates have opened, and the age we live in today is an age of commodity satellite imagery. There are hundreds of imaging satellites up on the planet, and they have extremely high resolution imagery available at very low cost, and they revisit pretty much every point on the Earth about once every 2 weeks. So you can see kind of the same location as the first IKONOS image in a commodity modern satellite. And you can start to see exactly, you can start to get a sense of how much the resolution of these images has improved over time. To kind of drive that point home a little more, here's a pretty standard government satellite image from 1985. It's about a little over a square kilometer. You can kind of see that there's some greenery, maybe some built up area, but it's not exactly clear just from this resolution what we're looking at. If we fast forward to just after the introduction of commercial satellite imaging, like, oh, this looks pretty familiar. This is Berkeley's campus. And even in 2003, you can pick out a lot more detail than you could in 1985. And when you zoom into this image that was just taken a couple of weeks ago, the resolution has increased, but what's really interesting about this particular image is that some of the haze correction and chromatic issues that were present in 2003 have been corrected as a result of better sensors and better preprocessing. So I think the trend in better resolution is pretty clear from this set of images. What might not be as apparent is that the quality of the signal that satellites are capturing has also increased. So a lot of early imaging satellites only picked up black and white imaging. So they were able to say that, oh, we know that there's aggregate higher levels of light being bounced off of this part of the Earth compared to this other part of the Earth. But there wasn't enough information to be able to distinguish between whether it's red, green, or blue. So very quickly, people started improving sensors so that we could get color images. And the way we make a color image is to just basically take a black and white photo, but focused on the three parts of the electromagnetic spectrum that human eyes can actually perceive. So that's red, green, and blue. But there are parts of the electromagnetic spectrum that humans can't perceive, but still have an enormous amount of information. So things like ultraviolet and infrared. And in recent years, we've seen the growth of multispectral imagery, which not only captures red, green, and blue, but also captures what's known as the near infrared band. So this is light whose wavelength is a little under 400 nanometers. What's interesting about this particular type of light is that the way that it interacts with bodies of water in particular lets us estimate not just visual features, but physical characteristics such as elevation, temperature, precipitation, and finer grained distinguish at a finer grain what types of vegetations might be present in a given image. So with the images I've shown and what I've described, I think it's not hard to imagine that Earth observation data is pretty useful for the physical sciences, and that's traditionally what it's been used for. So things like hydrology, geology, climate monitoring, weather forecasts. What we've seen in the last 25 years or so is that people in the social sciences have also started leveraging this kind of information. So I'll talk about some applications in economics. I think one of the more interesting ones that I first heard about was how hedge funds and various branches of the Feds started estimating changes in patterns in retail demand by looking at imagery of the parking lots in front of retail stores. So they look at weekly how many cars were filling up parking lots in front of Walmarts, and using that as an indicator for how much retail demand, how much consumer spending is going on. And if you've looked at some of the kind of real-time GDP forecasts, they're using signals like this. But beyond just daytime imagery that's captured by satellites, you can also look at nighttime imagery. So what we found is that as countries industrialize and electrify and build up their economic base, the number of electronic devices and light sources at night actually show up in nighttime satellite images. So this is an example of a nighttime image of the Korean Peninsula captured a couple of years ago, but the bottom half of the image focuses on Seoul, or South Korea more generally. It's one of the most industrialized countries in all of Asia. It has a relatively high per capita nominal GDP. And you can see that the greater Seoul metropolitan area is pretty lit up even at night because of the access to electricity. The top half of the image is North Korea. The government of North Korea claims to have a similar level of industrialization and per capita GDP, but you can only sort of pick out Pyongyang and Yeongdong in the images, in the top half of the image if you squint. So among other reasons, I would say this is a reason to doubt the North Korean GDP estimates. And then the kind of economic measurement that's most closely related to my work is looking at district level variations in relative wealth at a national scale. So this is the application I'll be talking about most closely and what a lot of my research has focused on in the last couple of years. So in order to be able to distinguish between relative levels of wealth throughout an entire country, you need a couple of things. As the title slides in this talk alluded to, the first thing you need is ground truth. So a big source of ground truth comes from the Demographic and Health Survey Program, which until recently was run by USAID. It's currently on pause, but we'll see what the future of it will look like. But this program runs surveys about every 5 to 8 years in a couple of dozen countries it mainly focuses on looking at demographic and health outcomes, but the questionnaire also asks a number of questions about asset ownership. So this is looking at the quality of housing, roof materials, access to sanitation, as well as ownership of assets such as bicycles, telephones, televisions, in rural areas like farming equipment. And from that, you can actually summarize all those asset ownership responses to get a sense of relative levels of wealth within a country. So once you have that data, you can also take satellite imagery, both daytime and nighttime imagery, and pass that to a neural network and use the neural network to find patterns in the satellite imagery that accurately predict the relative wealth levels that we got from the DHS survey. So unlike the first two applications I talked about, where the signal of interest is inherent in the picture. So if you're looking at cars, you look at the car, it's either there or not there. If you're looking at nighttime luminosity, you either see lights or don't see lights. In the relative wealth index prediction problem, there isn't one single visual feature that automatically tells you what the relative wealth of the area that you're imaging is. So what we've found, what similar poverty mapping work using neural networks has found, is that the neural network instead learns these proxies for land use and local texture that are then fed to further predictions to basically be able to say what the variation in relative wealth levels at the national scale look like. So this is some work from a couple of years ago that was looking at sub-Saharan Africa, and analysis of the neural network that was trained to run prediction here showed that one of the biggest internal classifications that the system was doing was trying to figure out the land use of the image. So whether it's urban area, farmland, coastal area, or desert, once that classification is made, then it's passed to further analysis within the neural network to make a final prediction. So in terms of how this works from a predictive perspective, in sub-Saharan Africa, it's been found to work pretty well. About 3/4 of the overall variation in relative wealth is explained. Once you move to South Asia, you get a little less. So like experiments in Nepal have shown that you explain about 60% of the variation. And when you get to places like the Caribbean, you drop down to only explaining about 50% of the variation in relative wealth. That being said, even an inaccurate estimate of relative wealth might be useful in places where a more traditional survey might not be possible. So in general, like these kind of proxy estimates are relatively low cost compared to traditional survey estimates. And even if cost is an issue, there might be strife or a natural disaster that prevents you from sending a survey team out there to actually run a DHS type survey. So this can be run completely independently. And because the underlying inputs update quite quickly, you can generate these kinds of estimates and update them in lockstep with how satellite imagery is being updated. Or at least that's kind of the sales pitch for a lot of the poverty mapping work that's been done. What we've actually found is that there have been a number of these satellite imagery machine learning estimates, but very few people have actually turned to operationalizing these. So what I've been working on in the last year and a half is to work with organizations and governments to once again show that these estimates are viable and how to actually integrate them into policymaking. So the first project I'll talk about is ongoing work in Nepal with the World Bank that's trying to integrate these satellite imagery ML estimates into survey planning. And then the second project is in Togo and Bangladesh with other PhD students here at the iSchool that's trying to push the scale at which we run these estimates down to the level of individual households. So in contrast to some of the methods I described previously, what we've been doing in Nepal has been leveraging a lot of the work and techniques in models that are very similar to large language models like ChatGPT, but taking those techniques and applying them to imagery. So instead of having a really expensive training phase where you're trying to learn all these filters that will tell you what the land use is, you can use pre-trained models that have already been trained on satellite imagery corpora and use the representations that are found there and augment those representations with multispectral features. This cuts down on a lot of the computational time. And what's even better about this is that prior work that kind of trained these models from scratch was able to explain about 60% of the variation in Nepal in 2011. Our work that uses kind of these more succinct representations in modern neural network architectures explains quite a bit more, about 70 to 80% of the variation in 2022 DHS surveys. And it takes advantage of both of the trends in Earth observation data I mentioned, not just more granular resolution over time, but the fact that you're using signals that are outside the human visible spectrum as well. So immediately what we're trying to do with this is feed this into additional survey planning. So the next round of like the demographic and health surveys in Nepal will probably happen in 2028. And what we see with these successive DHS surveys is that the results of the previous survey are used to determine the sampling locations of the next survey. So in 2028, the estimates of poverty and population that will be used to determine the exact sampling locations will be 6 years out of date. If we can update those, get like more granular updates of the changes in poverty and population using satellite imagery, we're potentially able to have a more granular and more refined sampling strategy in the 2028 survey than we would if we didn't have those intermediate estimates. The other potential way we could integrate this is we could look at what features the neural network is finding as important and pass them as what are known as a worker bee or workhorse controls to more traditional statistical estimates. I think I have a minute left. Okay. In the last minute, I'll say like when we actually generate these estimates, we generate them at about the level of like a 1 to 2 square kilometer grid. And like on a global scale, that's pretty refined, but at the level of like individual wealth variations, even that level of granularity, like papers over or averages over quite a bit of variation. So this work with Susana Constela-Vierslava and Emily Aiken, a former PhD student, is using geolocated survey data in Togo and Bangladesh to see if we can actually, instead of looking at like village or district level variation in wealth, we can push it down to the household level. And preliminary results are kind of promising. We're again explaining about 60% of the variation there, but because of this like increased granularity, I think we can cut down on errors of targeting and exclusion when we try to figure out where to send humanitarian aid or direct anti-poverty efforts. So I think that's the end of my speech. Thanks for listening. Hope you're excited about satellite imagery as I am. Yeah, thanks. I'll open it up for questions.
Okay, perfect. Hello, everyone. So exciting to be here. I'm Lauren. This is my first time presenting at the research reception, and it's just always a good time. So I'm so excited to be here today and talk about an interview study that I have been working on for the past year, looking at what I term advocacy technologists, which are tech experts within advocacy-oriented nonprofit and civil society organizations. Very importantly, this work is supported by all sorts of people and places across campus. Of course, Deirdre Mulligan, my advisor, as well as the Algebraic Fairness and Opacity Working Group, the Center for the Study of Law and Society at the Law School, and the Institute for Research on Labor and Employment gave me a grant, which was really, really helpful. So I feel like the easiest way for me to explain the genesis of this project is to talk about my own background. So before I came into the PhD program, I worked for 2 years at the Massachusetts ACLU as their staff technologist there. I was there from 2019 to 2021. So a couple important things happened while I was there. But it was really just an amazing opportunity to see the ways that advocates and sociopolitical change makers are really embracing using data and technology in new ways and to great effect. So some of the projects that I did while I was at the ACLU included making critical data more accessible. So this is a screenshot of a dashboard that I helped build and maintain that shows the rate of COVID inside prisons early in the pandemic, making that available to the public, to journalists, to family members, to researchers. We did some work countering false narratives. So this is a map that represents a database that we put together and then published that shows rates of police violence across the state of Massachusetts, which is one of those things that people think doesn't happen in Massachusetts because it's a blue state. So we had a whole campaign called It Happens Here that we were able to use this data to support. And then also things like revealing government priorities. So we did a lot of data around the time of the defund movement, looking into specifically the way that the Boston Police Department spends their money and what that tells us about what the government's priorities are, which was really interesting. All of this falls into a broad umbrella that is increasingly being described as public interest technology. I love to show this Venn diagram here in part because it encompasses like the breadth and ambiguity of this term. Like, of course, anything that ranges from artificial intelligence and machine learning all the way through computation and data on one side and social good, ethics, and justice on the other is like, some would say poorly defined. But basically, public interest tech has become a big tent that has kind of attracted a lot of people who are interested in these sorts of initiatives where we're using tech and we're using AI in support of these social good public interest issues. I've got a timeline that I'm going to walk through kind of quickly. We don't need to read every single thing on here. There's a lot, but basically trying to narrate how public interest tech has changed over the years and how I think we're entering kind of a new era of what this looks like. So in the late 90s and early 2000s, you can see I've got developments in academia, government, and civil society, or the nonprofit sector. We had all sorts of new initiatives spinning up. We had staff technologists being hired at organizations like the Center for Democracy and Technology and the Electronic Frontier Foundation. We had the government spinning up new developments like the Telecoms Act, putting information under the FCC, and we had DHS paying way more attention to cybersecurity. And we also have new research institutes that were popping up across the world focused on internet and society and the like. And so I think of this as kind of like the internet era. So all of these initiatives here are specifically focused on questions of this new thing called the internet and what we should be doing about it. In recent years, I would argue we're moving into this kind of new age of advocacy technology in which the people who are thinking about tech in these spaces are not only thinking about it in terms of the internet and in terms of online and digital services, we're also seeing it in, for instance, the CFPB, the Consumer Financial Protection Bureau, which is experiencing some interesting things right now. We're seeing, for instance, the AFL-CIO founded a tech institute in 2021. The Leadership Conference for Civil Rights also started a new project on technology in 2023. And we're starting to see new academic initiatives starting. A lot of these master's programs, which some of us in the room may have considered applying to or even did go to, that are looking at these intersections of policy and data and the ways that we can bring data to these, potentially more quote unquote qualitative situations like policymaking. And so this is kind of the background of the study. I'll give a kind of overview of the specifics of the method, so bear with me. The study included 23 conversations last year. I was specifically recruiting people who worked for an advocacy organization, almost always a mission-driven civil society group, and who had technological skills or expertise that they were using in service of that work. I prioritized specifically domains that historically have not been data or tech oriented. So this is kind of the breakdown of who I talked to. And I'll say like the modal organization here is in tech and digital rights, but I also talked to folks in climate, in criminal law, in electoral politics, people who work on social safety net and basic needs, all those sorts of things. People in all of these domains are bringing on technologists into their work. Thanks to the IRLE, I was able to provide an honorary to talk to folks. I talked to them for 60 to 90 minutes, and I used a combination of qualitative methods involving flexible coding and reflexive thematic analysis, site to site, in order to kind of come to the conclusions that I'm excited to share. So I've got two sets of results that I'm going to be sharing today. The first is about the career pathways of these advocacy technologists, and the second is around patterns of praxis praxis that I saw arise in the conversations I was having with these really cool people. So first, the career pathways. I was able to identify kind of 3 cohorts of folks that I talked to that felt like they were from kind of distinct points of entry into the advocacy technology space. The first I called homegrown critical technologists. So that was 8 of the 23 people I talked to. These folks grew up while the internet was growing up. And so they remember a time kind of before the internet being pervasive in our lives. And most of them have spent their entire career thinking about the sociopolitical aspects of technology. The second group I call socio-technical converts. So this was 6 of the 23 folks. These people usually began their careers in nonprofit work, activism, law, organizing, and then came into tech through that, where they maybe realized, this thing keeps coming up. I would love to learn more about how technology is affecting this work. You can't see under the transcript, but I have an or vice versa there, which is doing a lot of work because also sometimes people start out in tech, as you can imagine, and maybe have a come to Jesus about the ways that they might want to think more about sociopolitical effects of their work, and so might kind of come into the work that way as well. And the last I'm calling socio-technical natives, which is a callback to the term digital natives, which has to do with the young folks these days who grew up never not knowing what an iPhone is. But 9 out of the 23 folks I talked to, I would put into this category. These are people who are in their 20s and early 30s. They left college with technical skill sets already, and they immediately sought work on sociopolitical issues. So I see these people as really being kind of the vanguard in the forefront of what public interest tech and advocacy technology looks like, because we've got this really devoted kind of cohort of, I want to call them kids, but they're not kids, who are graduating and are already really concerned about all these problems. So that's the career pathways. The second category of results has to do with patterns of praxis. So I identified 4 different patterns that kind of popped up throughout all of my conversations around translation, interrogation, introspection, and trailblazing. This is the part of the presentation where I should have killed some more of my babies. So I have maybe too many quotes here. We're gonna try to go through them quickly. We'll see how it goes. So for each of these, I'm gonna pull out kind of 2 sub-results that I hope are descriptive and give a good sense for what I mean when I talk about these patterns of praxis. So the first being under translation, we saw a lot of ways that these participants, these technologists, would be at the interface going back and forth from a goal to an implementation. So they talked about being a translator, going between what someone's asking for and what's actually possible to build. And having to explain sometimes that just because the data exists doesn't mean that it's easy to use. So going from what maybe their boss's image of what a project could look like would be to actually what that means when you turn it into data and code. The second subpoint here I call shining light into black boxes. So that has to do with kind of opening up the ways that the tech industry perpetuates narratives and creates products that are opaque and complicated. I have this really lovely quote I love from one of my participants who was kind of saying that they hear people kind of cutting themselves out of these conversations saying, maybe I shouldn't say anything. And they say, you do understand. This is 99% something you understand. We can teach you the tech part of it. Don't just completely remove yourselves from the conversation because of the tech elements in these social problems. Okay, within the interrogation, the first trend was the ways that these technologists are resisting hype and magical thinking. One person said that we've all been duped by these platforms. We now know they're not out to help us foment a revolution or defend human rights. They're just trying to collect our data. They're not here to save us, especially in the age of AI that we all find ourselves in now. There was a lot of discussion of people saying, everyone's coming to me and saying, how can we use AI for this? Can we use it to predict this? Can we use it to solve that? And one person said, quote, no, we can't do that. We have no data to do that with. And even if we did do that, it'd be stupid, like it would be useless. So kind of having to push back against this magical thinking that's coming up a lot with AI these days. And the second point around rejecting techno-solutionism and centering people and problems instead. So thinking about the ways that going for an Uber for whatever, an AI for that is just flushing money down the toilet. Because ultimately, a lot of what matters around organizing and political work is around relationships between people. And quote, there's not a lot that tech can really contribute to that. Thinking about the introspective piece, I saw across the board, all of these folks were super dedicated to work that was meaningful to them. One person shared that they know people who work at Facebook, where their job was, quote, to go in and fight for child safety and to lose every day. And while those people might be paid out the wazoo, this person had a hard time thinking that that would be rewarding work to do. And another kind of voicing, a younger participant voicing that maybe they're naive, but they really want the things that they spend most of their hours in the week doing to align with their moral values. This also looked like evaluating the impact of their work. So I had more than one participant talk about things like the nonprofit industrial complex and the ways that bureaucracy and organization can in some ways defang the most revolutionary of movements and being attentive to that. And I have this very silly bullet point here, which is that everyone's having an existential crisis. So I got, what are we doing? Are we just a part of the system? Are we making sacrifices by working at a big nonprofit? Is this ever going to help anyone? What am I doing? I have to go back to school. Are we getting anything done here? What's my work actually adding up to? What are we doing in the world? So these people are really tortured about the ways that they are or are not contributing to society. I relate to that. And then last, trailblazing, these folks have faced uncertain paths and have uncertain paths ahead of them. One said, if you like math and don't want to do evil, there's not really a good pipeline for you. Someone else said, we just don't know what's coming because no one has done this before. And oftentimes these folks would find themselves as a team of one on an organization that maybe has no other technically trained people in the whole group. And so they might find themselves feeling like an appendage or having to go outside of their work to find mentorship or collaborations that they simply cannot find within. Whew, there's all my babies. Okay, so here is kind of an overview of all of that, but why does this matter? So maybe this is a little straightforward, but part of this movement towards public interest and advocacy technology is really plugging into larger movements that we're seeing across the country and world, from labor movements to more critical academic work on technology and critical political movements, bringing more criticism to tech companies that are supporting war efforts or stealing data from artists and musicians or canceling LGBTQ focused policies at the biggest tech companies in the world, all of these sorts of things. So the existence of these advocacy technologists and their choice to go into civil society at a pay cut is working against the notion that all of this is just business as usual. And it's also kind of throwing a wrench in the idea that tech is this exceptionalist industry and we should hold it up as the paragon of human innovation. And no, we're saying this is also something that we should be critical about and that we shouldn't necessarily be just rolling over as all of this is happening. And of course, there's also some really concrete benefits to having these sorts of technologists in these organizations. So you bring more technical expertise into advocacy work. So that might mean coding and data analysis as a quote, new kind of reading and writing, ways that you can use technology to help make policies actually happen more efficiently and effectively. And just generally better understanding the technical parts of issues that have been there for a long time. So, you know, we've had problems with reproductive health in this country for a long time, but the new threats of data privacy are kind of a new and unique element of that advocacy organizations maybe aren't as equipped to understand without having these translators on their staff. Similarly, we can bring advocacy into technology. So that looks like bringing the critical voices and expertise of these advocates into processes of tech design and governance, and in doing so, making legible these otherwise liminal spaces of tech protest, refutation, and refusal. And what I really love is that all of these people, I feel like, are living out the creeds of so many critical socio-technical scholars past. So Deirdre Mulligan and Kim Bamberger wrote about the importance of building in-house technical capacity to rectify the uneven technological expertise among stakeholders. Chris Bopp talked about individuals who could work around imperfect and incomplete data. Steve Jackson in the Policy Knot paper wrote about recognizing the creative and generative interplay of design, practice, and policy. And way back in 1997, Philip Ager talked about the importance of having people with one foot planted in the craft work of design and the other foot planted in the reflexive work of critique. I argue that the folks I'm talking to are this, just like incarnated in reality. And I find that really helpful and exciting. So I think that's all I have to share. Here are the things that I'm kind of working on. I've got other advocacy tech related projects around funding and pedagogy and the specifics of work activities, but I think I'm over time. So I will.
Okay, hi everyone, I'm Dan, thanks for coming. Yeah, and today I'm going to be talking about a project called the Peripatetic Hater, Predicting Movement Among Hate Subreddits. This is the paper that got accepted to ICWSM this year, so I'm very excited to talk about it with you all. It probably feels all too common to see headlines like these in the news, where the perpetrator of some mass shooting is shown to be involved with an online hate community, some community that is dedicated to disparaging some sort of marginalized group, whether that be a white supremacist group or incels or things like that. And the harm of these online hate groups isn't just limited to the offline violence displayed in these headlines, but also it extends to the psychological toll that hate speech might have on marginalized groups, or the fact that they keep perpetuating harmful stereotypes about these groups. And so it's important to understand the role that these groups play in shaping online discourse and how they grow and continue to attract new users. And Reddit in particular has in the past either platformed or deplatformed some of these groups. And so this is sort of a motivation for using Reddit as a source of data to understand online hate communities. To focus in a little further, there's this idea of the gateway community in online hate communities. Okay, for the new advocates, this is a picture of a fancy new building we're building called the Gateway. I didn't mean to imply that there's an incel to UC Berkeley pipeline. I think I'll leave that for future work. That's outside the scope of the project. But this idea is that if you join one hate community, that you are then more likely to join a different kind of hate community. And prior research has established that there's a strong overlap between the manosphere, a collection of anti-feminist communities, and the alt-right, for example. But most studies of hate communities on Reddit only really focus on 1 to 2 core ideologies, or they'll just do case studies of a handful of hate subreddits. But no one's offered a sort of comprehensive view of like, what are all the types of hate subreddits that we see on the platform. Also, there's this interesting question here where these communities aren't static entities, right? They're shaped by the people who participate in them. And so how do these separate but related communities that have a lot of overlap in users, how could they influence each other? Yeah, and so that's sort of the position I take with this paper. So here are research questions. One is, generally speaking, are users who participate in one type of hate community more likely to participate in other hate communities of different types? And how might joining these additional types of hate communities affect user behavior? And given that a user has already participated in one kind of hate community, can we then predict what are the types of hate communities they participate in the future? So first, to get this big list of hate subreddits, we turn to a bunch of different sources, but one of them is called the subreddit called Against Hate Subreddits. And a lot of times users will post lists of hate subreddits to this subreddit. And so we look for those lists and use those, as well as lists obtained from prior literature and Wikipedia as well. And so we end up with this list of 168 subreddits that have greater than 1,000 users. And those are the subreddits we use in this analysis. We then measure 8 different kinds of hate speech in each of the subreddits. This is racism, xenophobia, anti-Semitism, Islamophobia, misogyny, transphobia, homophobia, and ableism. And we are able to measure these because we use a model trained on the Measuring Hate Speech corpus, which was developed here at UC Berkeley. We then use a clustering algorithm to group these subreddits into different groups based on the levels of hate speech in those 8 different categories. And so what we get is 8 distinct categories of subreddits that roughly map onto the types of hate speech that we measured. But one of our clusters is high in both homophobia and transphobia. And so that's our anti-LGBTQs cluster. And so this includes subreddits like Against Gay Marriage or Gender Critical, which is a trans-exclusionary radical feminist subreddit. We also have a misogynistic cluster, which contains a lot of the different sects of the manosphere. The anti-Semitic cluster has a Holocaust denial subreddit, as well as some Nazi-related subreddits. And then there's this big cluster of subreddits that are kind of equal in all the different categories of hate. So we call these the general hate subreddits. And these are like dark humor subreddits, like r/offensive memes, or subreddits that are meant to be kind of anything goes, do whatever you want, like cringe anarchy. And so now that we have this categorization of subreddits, we can then ask our question, are users who join one type of hate subreddit likely to join other types of hate subreddits? And we do this by, for a given category of subreddit, we match each user to a similar user who did not participate in that original category of subreddit. But these users are similar in the other types of subreddits they're active in, and also their general activity on the platform as a whole. And we ask which user is more likely to participate in these other types of hate subreddits in the future. We find that regardless of the original category, that the people who join that original category are more likely than the users they're matched to participate in different kinds of hate subreddits. We call these users who participate in multiple types of hate subreddits peripatetic users or peripatetic haters. Another question we ask is, are there certain preferences that peripatetic haters have for certain types of groups? So given the group that you start out in, are you more likely to join, which groups are you more likely to join? And so the way to interpret this heat map here is that if the ratio is higher, if the number is higher than 1, if it's purple, then that means the users are more likely than expected by chance to join that alternate category of subreddit, where the diagonal line means different subreddits in the same category. And so we find generally users prefer to stay in their own category of subreddit, but the racist, xenophobic, Islamophobic, and anti-Semitic subreddits show a strong degree of user overlap, which makes a lot of sense because those types of hate speech are very intrinsically linked. Yeah, and so then going to our next part of how might joining additional categories of subreddits affect user behavior. The way we think about this in this study is this idea of in-group language of the subreddits. So you have your different kinds of haters inhabiting these different types of subreddits, and there's some set of language in these subreddits that's sort of characteristic of these communities, that's distinctive. And one thing that could, and this could be, you know, the types of hate speech that characterize the communities, or it could just be memes that originate in these communities and are mostly shared within that specific category and not the others. But one thing that could happen with these peripatetic haters is that one hater could leave their community and then post in another community, and then suddenly they've adopted the language of the other communities. And when they come back to the misogynistic community, they start using language from another community that they've participated in. And we look at this in two different ways. One is, do users use more language associated with the alternate subreddits that they join after they become peripatetic or become active in a different kind of subreddit? And we look at this comparison for all the different combinations of subreddits. And here, if the number is in the square, it means it's statistically significant. And the red values mean, yes, peripatetic haters use more language associated with alternate subreddits after they become peripatetic. But another thing here is that the peripatetic haters, they could just already be interested in the types of topics discussed in the alternate categories they join, or they could be lurking the alternate categories before they post. And so we also compare the peripatetic users to the non-peripatetic users who only stay in their original category. And this time we ask the question, before posting in an alternate subreddit, do peripatetic haters use more language associated with those alternate subreddits than those who do not post in those alternate subreddits? And again, we find most of the time the answer is yes, that peripatetic haters use language associated with the alternate subreddits than the non-peripatetic haters. And so this is kind of, this kind of gets at the final research question we had was, can we predict which subreddits users will end up in based on their activity before they join those alternate types of hate subreddits? And so we train a predictive model using the comments that each user posts prior to joining alternate subreddits. We also include information about the original category they join, and then we predict what is the probability that they join each type of hate subreddit in the future. And we also experiment with training on text that users reply to, as well as the text that they write, because we thought that they might be exposed to some information about the additional groups that might be informative for prediction as well, even if they're not explicitly writing it. And so these are the ROCAC values of our model, and this target column means we train the model only on the text that the users write. The context means we train on the text that they reply to. All means we train on everything. And basically, if these values are greater than 0.5, it means that we do better than random chance at predicting these. And ultimately, we find this is a challenging task, but we do better than random chance at predicting who becomes a peripatetic hater, which categories they join. And so this indicates that there's some sort of features that the model is picking up on, that it's indicating they're more likely to join certain types of hate groups, which could be useful if a platform wants to provide some sort of proactive intervention targeted at these sorts of influential users. So to conclude, this kind of speaks at an interesting issue that these online hate groups might be worse than the sum of their parts, where if joining one group means you're more likely to join another group, And these groups influence each other, perhaps spreading different kinds of hate speech, cross-pollinating them across the different kinds of subreddits. Then that means that the subreddits may become more general in terms of which identities they target over time. And even if the types of hate expressed in an individual subreddit become more diverse, the subreddits may become more similar to each other in the fact that they all kind of hate everyone. And that's very concerning. And it might speak to the affordances of a platform like Reddit, where you have a very low barrier to entry to creating topically distinct communities and also participating in them so information can flow among communities very easily. Future work can explore this problem in more detail by examining what role do peripatetic haters play in making subreddits more extreme, and do peripatetic users act as a sort of recruiters? If you interact with one, are you more likely to join a different subreddit in the future, which could then establish more of a feedback loop of this system is getting much worse and worse. And with that, that is my presentation. Thank you very much.
My name is Naitian. I'm a third-year Ph.D. student here at iSchool where we're examining. And today I'll be presenting an ongoing project where I study the visual aesthetic of About Me web pages. But first, I want to spend some time providing a little bit of motivation for this project. So the academics in this audience know that a good portion of our time, maybe even most of our time, is spent on one task, and that's stalking the websites of other academics. Maybe someone is giving a talk, maybe you read their paper, whatever it may be, you end up Googling them and reading their website. And what you discover is that they all kind of look similar. Similar font or color choice, similar layout. This is especially true if they all work in a similar field. Or if they both happen to get their computer science PhDs at CMU at around the same time and also share the same first name. And if you think about it, this shouldn't be that surprising. After all, we use our websites to display ourselves to the world. And in a way, you can think of this as like digital fashion. We choose a style that we think represents who we are or how we want to be perceived. In other words, our style contains social meaning. And this is a fundamental idea in sociolinguistics. We use language to not only communicate a message, but also use our linguistic style to express our identity and how we relate to each other. Let's walk through this distinction with an example. We can consider this interaction where Alice is trying to buy a soda from Bob. And here we'll focus on Bob's response to the interaction. So a semanticist might formalize the meaning of this sentence using something like propositional logic. And so what Bob's sentence means, the simplified semantics, is that Bob doesn't have soda. But this isn't the only layer of meaning. There is also discursive meaning, or what Bob's response is doing in the interaction. That's a rejection, right? Bob is rejecting Alice's request for a soda. And Bob's word choice also contains social meaning. Soda is more common form, is more of a common term here in California, but pop is often used in the Midwest. And so this linguistic feature, the choice of pop over soda, indexes a Midwestern identity. And understanding how linguistic features can index particular identities or social meanings is a central focus in the study of sociolinguistics. And so the field has developed some theoretical foundations to help us understand how that happens. The first mechanism is indexicality. Different linguistic features can index different aspects of identity. So saying pop instead of soda might index Midwesternness. But there can also be higher order indices that index more abstract concepts. So saying pop might instead index a certain unpretentiousness that has its roots in the working class history of many Midwestern cities. And so a feature can index multiple social meanings. And we can combine multiple features together in such a way that we can disambiguate between these meanings and end up with a coherent style. This process of constructing and combining is called bricolage. So indexicality and bricolage are kind of these theoretical mechanisms that we can use to understand how we make social meaning out of linguistic science. So I can extend these concepts beyond linguistic structure to a visual mode of communication, like website style. You can see how some websites might aesthetically index different identities, or draw on stylistic cues to link with certain ideas or attributes we want to project to the world. And together, they combine to convey something coherent about each person. I hope you now feel a little bit more convinced, if you weren't already, that the visual style of websites is one way out of many that we communicate social meaning to others. And so the question in this project is, how can we computationally model these meaning-making processes? Computational sociolinguistic research is difficult to conduct at scale. This is partly due to the ambiguities of natural language. So a sociolinguistic variable is different ways of saying the same thing. And so it requires linguistic knowledge to be able to identify, for example, that pop and soda mean the same thing, or that using a different vowel when pronouncing a word doesn't change its meaning. Another complication is the ambiguities of social categories. Most computational work relies on these global top-down categories like nationality or gender as categories for identity. Meanwhile, a lot of sociolinguistic work that focuses on locally relevant meaning tends to rely on ethnographic data. In this project, we study websites as a way to sidestep some of these limitations. Sociolinguistic variables are hard to identify because natural language is ambiguous. And so instead, we use the highly structured CSS code that defines the visual properties of websites. CSS is a programming language with a defined syntax from which you can extract style rules, like what the font is. This is useful because unlike natural language, the variables are predefined for us. Each CSS property can take on a range of different values. And so these are the different ways of saying the same thing, our sociolinguistic variables. For example, the font family property could be Helvetica or Courier or any number of other fonts. So CSS removes the ambiguity of natural language, allowing us to take advantage of the structure of the coding syntax instead. The other challenge is that social meanings are ill-defined. So we use a data set that mines for self-declared social roles from the web page. We're building on a corpus constructed by Lucy Lee, who's another student in David's group, and whose website you might have seen earlier. She scraped Common Crawl for About Me websites, and mined for metadata from these pages, including their topic and their self-professed roles and occupations. This gives us valuable social information that's not imposed from the top down. And what's more, the fact that these roles appear on their website along with CSS styles means that they're most likely using the website to convey this particular stated aspect of their identity. And so Lucy's data set doesn't include the CSS styles, so we go back and fetch as many of the style sheets as we can for the websites in this collection. And so we end up with approximately 60,000 pages that we recover all or most of the CSS for. And using the CSS rules that we extract, as well as the metadata from the About Me dataset, we can begin to explore the mechanisms of indexicality and bricolage as they apply to website style. In the rest of the presentation, I'll cover 2 case studies on font choice and the social meanings that they index before spending a little bit of time at the end talking about future directions. The question that I'll start with first is a simple one. How might font choice reflect or convey the topic of a page? I start by parsing all of the CSS files that we collected and extracting every font family rule. Then I group these fonts into several broad categories like sans serif or serif and monospace, just to make it a little more tractable. And I match them up with the topic of the page that each rule appeared on. Now I can use a method called weighted log odds ratios to identify which page topics are overrepresented for which categories, font categories. And what we find is that pages with serif fonts are far likelier to have topics like blogging or literature, topics related to writing. Pages with sans serif fonts are likelier to do with education, fitness, or community. Pages with monospace fonts are unsurprisingly likelier to be tech related. It's also worth noting that sans serif fonts are by far the most common in general on the web, which is why you might see a greater variety of topics there. We might try to interpret the findings from the last slide by drawing generalizations about, for example, why blogging literature topics would both skew towards serif fonts. So the question is, what ideas do serif fonts evoke that make us think of like literariness, for example? I operationalized this by building on a method called contextual semantic axes, which also happens to be one of Lucy's papers from a couple of years ago. And the basic idea is we can construct a semantic axis between two opposing concepts using a language model like BERT to generate vector representations for words. Here, for example, we construct a semantic axis between ugly and beautiful, representing the concept of beauty. Then we can project the representations of a target word like women onto this axis. And its position tells us, according to the language model, whether this target word representation lies closer to beautiful or ugly in its usage. We follow Lucy in constructing 512 different semantic axes using a linguistic resource called WordNet to seed our opposing adjective pairs. So then the question is, how can we use this method to tell us about fonts? Once again, I first grouped the font rules into broad categories, but this time, instead of comparing the high-level topics, we map onto the self-professed social roles. We once again calculate the log odds ratio of each role for each font category, but this time we actually rank the roles. This is essentially an ordering of the most representative to the least representative roles for each font type. Now we have role rankings for each font category, and we can also calculate the role rankings for each of our semantic axes. Essentially, we're sorting each role from most beautiful to least beautiful, for example. Then we can calculate the rank correlation between each semantic axis and the font categories to see which are the most correlated with each other. One way of understanding a high rank correlation between monospace and functional, for example, is that the functional semantic axis offers a good quote unquote explanation for how relevant different roles are to the monospace font. When we apply this method to our data, we find that we surface correlations like serif fonts and the national and permanent axes, while monospace fonts are correlated with axes like practical and functional. So this method can offer a view of more abstract meanings of font usage. So here I've demonstrated a couple of findings that relate to indexicality using one particular feature, the font choice. But I alluded earlier to this idea of bricolage, which is that multiple features combine to form a coherent style. And so now I'm building a model to predict the social roles using all of the CSS rules on a page and designing it such that we can use the model to better understand the bricolage process of combining features. I won't go into any details about this phase of the project. It's still very much a work in progress. I have the models training right now, but I'd be happy to chat more about it afterwards if you're interested. Now I want to leave you with kind of three core ideas, which I think even the results that I presented today can support. The first is I hope that the preliminary findings that I presented here serve as a good demonstration of how we can use sociolinguistic theory as a lens through which we can understand the structure and meaning of extralinguistic data like CSS styles. Also want to point out that this kind of study would be really difficult to do on natural language. And so using this extralinguistic data actually offers us a foothold to begin modeling something like indexicality using large-scale computational methods. And finally, I hope that I've offered some convincing evidence that there's more to language than the semantic meaning of a word or a sentence. And so in order to understand language and build systems that understand language, we have to understand other kinds of meaning, like social meaning as well. That's all I have today. Thanks. I'd be happy to take any questions now. And
Awesome. I want to thank everybody for their attention. I'm really delighted to be wrapping up. I've heard some great talks, excellent research going on, and I hope that this sort of stands to muster against some of my fellow colleagues here. So my name is Stokes. I'm a fourth year PhD candidate here at the School of Information, advised by Marty Hurst. And today we're talking about some work that we did examining how visualization designers use writing in their design process. So we completed this work actually also with the help of Clara Hu, who was a MIM student here at the iSchool as well, and was greatly instrumental in the coding processes and some of the inner workings of this study. We also presented this work at IEEE Viz last October, so I'll have a paper link at the end if you are interested in that for whatever reason. So visualizations are really, really powerful ways of communicating information. They catch your attention and they leverage this kind of visual processing system and pattern recognition that we have developed over thousands of years. So they're hugely important. You saw some great visualizations earlier today as well, and they convey a lot of information. And usually in my work, I focus on these elements of the charts. So titles, captions, annotations, that's sort of my bread and butter. Usually I will write a survey on Qualtrics, put it on a crowdsourcing platform, compare responses to changes in these text elements, and make some conclusion about how you should write your titles this way and not that way, or something of that sort. But for this project, it took a little bit of a different angle on it. So this is an interview study focusing on the visualization design process. And part of why that's important is that there are a series of choices made by the designer for a visualization like this that result in the chart that we see here today. So for example, there are lots of questions around data processing and grouping and how you might handle different cases of issues in your data. There are lots of questions about the visual display itself, chart type, color, different arrangements of data. This is all stuff that's really rich in the visualization field. There's a ton of research on it right now as well. And there's also the stuff that I work on around the text, such as, how might you use this text to accompany your design? And each of these questions is sort of critical to getting to this end state of a visualization that effectively communicates whatever it is that it has inside it. And so this project started based on this kind of central motivating question around how we can help visualization designers actually navigate this very complicated design process. But because I'm interested in text, I actually asked specifically, how can we use writing in particular as part of the visualization design process? And does that, have an impact on what that looks like? So when I say design process, that is a very vague and nebulous thing that looks very different across different industries and different people. But we use this sort of design activity framework from prior work in visualization research to structure what we talk about. So first, designers use some research or investigating to understand user needs and the kind of asks that they have from this design. Other things that they're working with as well, such as deadlines or display limitations, like if you're working on mobile versus desktop. Then they start iterating on ideas to kind of support those goals and work within those constraints to come up with some way to visually communicate this information. Then they make these ideas into prototypes that are basically functional in order to test some aspect of those design decisions. And then they send that design out to the real world setting as a visualization or visualization system. But designers don't really move through stages like this so neatly. If you talk to any one of them, they'll tell you that over and over, like it does not quite look like this, but these are really helpful stages for helping us understand, when does something happen broadly in the design process. So we use it, but it's not exactly reflective of what an individual's process might look like. And we already know a little bit about what kind of steps visualization designers take. So sketching and wireframing are two substantial components in the visualization design process. And they're also a big part of how we teach visualization design, particularly before students get familiar with Viz tools. So it's really a lot easier to sketch a bar chart than to make it in D3. So it's often really helpful for them to learn how to do that first before they get into the tools themselves. But researchers have not yet explored the use of writing in the design process. And when I say writing, I literally mean writing stuff down, ideas, concepts, key points, questions that refer to the visualization of the data itself. In other disciplines like search, even writing down your questions ahead of a search process can help lead to more effective processes. So, we haven't looked at this yet, but there are a couple of reasons why it might be an interesting factor to look at. So first, as I mentioned, we use sketching and wireframing to teach visualization design. You can imagine that writing might offer another key way to kind of structure some of that visualization design learning process. So by outlining those key ideas prior to visualizing them, maybe students will be able to better understand their design choices and the motivation behind them. We can also use written artifacts as a corpus for training models on design choices and decisions. And so, perhaps a given chart type is often used to achieve a certain goal or outcome. And so you can kind of match those things up and train a model to help designers make those decisions quicker. And now more than ever, we're also seeing natural language interfaces and large language models being incorporated directly into environments for data exploration, analysis, and visualization. So reading and writing are bigger and bigger parts of visualization design. And so by better understanding how designers do and should use writing, we can help contribute to that space as well. So in this study, we coined the term writing rudder. So in this case, we think of it like the rudder of a boat. Right? It's going to guide and steer and assist the process, but it's not, going to be the same thing as design requirements. So it's sort of different, it's like a more lightweight approach. And the idea here is that you're writing down messaging, story, or key goals of the design and to help kind of shift your trajectory, so to speak. And we asked two main research questions here. So first, do designers already do this? Is this something that they do very well in practice and we just don't know because research tends to be a kind of siloed thing when we talk to designers? So maybe this is already happening and that would be a great finding. Spoiler alert, it is not what's happening, so good thing because we got a paper out of it. Next, we need to map out what is the effect of writing on these processes. What is the impact of writing? Should we recommend it to designers or is it actually really detrimental and they should just stick with the sketching? So to do this, we recruited US-based visualization designers who were fluent in English and designed visualizations as part of a paid role. So we used channels like the Data Visualization Society listserv, as well as public posts to LinkedIn and X. And in the first study, we recruited 24 visualization designers to complete a semi-structured interview. We first collected some kind of information on what tools they used, what context they worked in, and a little bit more about who they were. And to give you a little bit of sense of who participated, we had a variety of industries represented here. So journalism, medical industries, nonprofit work. When I say scientific and technological services, that often means consulting broadly, but it's a better word than consulting and it captures more participants. And they also used a variety of tools. So predominantly relying on Excel, also Tableau, some kind of other ad hoc tools. But really what was happening is designers were using multiple tools for different parts of the design process. So that's why you see that these numbers don't add up to 24. And they also made a different set of design outputs. So creating often more than one of these dashboards, text and visual reports, a lot of live presentations as well as sort of other aspects. But again, mostly making more than one depending on the context or they ask. So we're pretty happy with that range of visualization designers, captured a bunch of different fields, a bunch of different practices, and a bunch of different contexts in which people might work and what they might make. So during the interview, we discussed their design process, so including specific tangible actions that they were taking, as well as what were their roles and responsibilities in visualization design. We then also walked through an example design to kind of help ground that discussion. It's one thing to talk about your design process in theory. It's another thing to look at a design and I ask you, how did you make this? So that was really helpful in getting a sense of that context that they really worked in. And in the last section, we talked about their use of text elements like titles, captions, and annotations. Now you might have said, Chase, you said you weren't going to talk about that, and I'm not going to. That is a different paper, a different research question, and it's under review right now. So we're going to focus on the kind of first half of this interview where we talked about the design process and looked for instances where designers were using writing in that process. So here we have all of our lovely participants. We sorted them based on coding these interviews into one of three categories. So 1/3 of participants did not use writing at all. They actually found it really weird for me to ask the question. It's not something that they really thought of as part of the visualization design process whatsoever. Another third used it in kind of an incidental way. So they would do things like, oh yeah, I take notes during meetings, or we do user interviews and I use the transcripts, but they're not really using those and applying those notes and transcripts in the same way that we were looking at to sort of guide the design specifically. And it wasn't kind of the scale of writing that we were looking at or looking for. But the rest of participants did use writing this way. They used these rudders. It was a way for them to guide the design process. They would take notes on their phone or write things down on a sheet of paper before diving into the tool, very similar to how you might do sketching in the typical design process. And this use of writing tended to occur in those early stages. So when they were understanding and getting a sense of the data and their users' needs, and also when they were starting to ideate different designs and kind of see how they could fit those needs. So when we return to our research question, we can kind of answer with two insights, right? First, it is not a very common practice. 2/3 of our participants did not really think of this as a concrete step in their design process. And so that really opens up the floor for us to kind of examine this as a really interesting and underutilized potentially tool. And secondly, when designers do use writing rudders, they do so in those early stages. So that's sort of how we started planning out this study too, where we then went on to ask, what is the effect of these writing rudders? And to figure out how to test that, we looked back at the transcripts from study 1, and we picked out 4 examples of how people talked about using writing. So in particular, designers could write down key questions that the design was aiming to answer or that the reader might come to the visualization with. They could do the opposite side. They could write down the conclusions that the reader might walk away with. They could write a paragraph or a few sentences about the story behind the data and do a little bit more like narrative work there. Or they could write down possible titles for their visualization. This last one was really only common amongst data journalists, but it was still useful for us to look at, in part because data journalism is a really interesting field where you have to communicate to broad audiences. So this is something that we really wanted to take a peek at. In this study, we recruited 15 participants, same methods and same pre-survey to collect some of that basic information. In this case, we get a variety of industries, not quite as good as the first study, I'll admit, but still pretty decent. Research is pretty broad industry and nonprofit and government as well, really represented there. And they still frequently used Excel, but here they're using a bit more of Illustrator that has to do a little bit with the differences in industry that we see as well. But again, many designers still use more than one tool in their process for different contexts and different use cases. And the outputs were also still varied. Again, some more emphasis on text and visual reports, dashboards a little bit lower here, but that's because not all of them were working in consulting. So you get that kind of trade-off there. The interview began the same way as study one, with conversation about designer practices and approaches to visualization design. But this is where the protocol deviated. They then went on to complete a design exercise. So they were introduced to the writing letter variants that we were looking at, selected the one they found most interesting or useful after we kind of talked about them a little bit, and they began the design process. The exercise itself only lasted 10 minutes because we were really interested in looking at that beginning stage, and also because we were constrained by time, and it's easier to do 10 minutes. And so they were given a year of real Chicago weather data, including temperature, precipitation, and wind speed. And they were asked to help inform a marketing team about when to deploy ads for waterproof windbreakers. So these are the instructions they received in sort of one side of the Google Sheet. The data would be in the other sheet on that workbook. And then you also have the writing steps that they would complete literally in that workbook as well. And they could use whatever tools they felt most comfortable with or they liked the most. A lot of people ended up just using Google Sheets because it was already in there. But as we saw, a lot of people use Excel, so it's a pretty relevant tool as well. So after they completed the exercise, we reflected on how it went, talked about what the impact of that rudder was, if there was any, how they thought about it, things of that nature. And then they also completed a post-interview survey where they provided ratings for each variant across those different stages of the design process, including and especially those early stages that we mentioned earlier. So let's first look at what participants selected and some example responses, and then we can get into kind of what they thought about these. They tended to gravitate towards the use of key questions. So that's 8 out of our 15 participants there seemed to align with how they thought about approaches to visualization design in general. So for example, one key question that a user asked here is about when during the year a windbreaker would be required. And obviously that will help inform our marketing team as to when that peak season might be. Possible conclusions, right? Sort of that inverse of key questions. This was selected by a third of participants. And since this step took place before the designer really started visually exploring the data, they may not know what trends are actually present. So here you have an example where they're claiming that wind is really high in March and April. That may or may not be true. Wind is pretty high year round, actually. So in those cases, or in other cases, rather, designers would use X to indicate that they didn't know what the month would be, but they still wanted to write out this possible conclusion. This was true for 3 of those 5 participants. So they're thinking about the kind of information a reader might be taking away, but they're not prescribing what that will be before they get to the data. And 2 participants selected the narrative, and in this case, they really used it about like situating the visualization in the context as a whole. So here you have them describing, weather is related to this, and if we look at the weather records, we can see these trends maybe. So it's like kind of a paragraph version of the conclusions. And nobody selected the time option, and I'll get into why. But overall, participants thought that writing rudders would have a positive impact in their design process. So those are those dark blue bars you see. Light blue is neutral, orange is negative. We completed some open coding of these interviews to understand what the impacts of these rudders were and how the variants differed, right? You may be able to see some variant differences visible here. And in particular, at first we looked at why designers preferred this question and conclusion step. So they really found that it added to the focus of their design process. They had this sort of guide, this rudder, if you will, to guide them through this process, to focus them on these different questions or conclusions. And they found these approaches also useful in focusing on the user and maybe how they're coming to the visualization or how they're walking away with it. So we found this sort of interesting user focus that was added through this step. And we focused on the beginning stage of the design process, but we also had people tell us how they'd be useful later on. So one participant here describes a hypothetical conversation with a client where they say, I wrote these questions before I started designing. Does the design answer these questions? Can you use this to help evaluate my success as your employee or as your consultant? And this was also true for the narrative case as well. But for narratives and titles, people are all pretty concerned about bias. So you're stating what's going to happen in the data before you've looked at the data. That sounds like a problem. And so in these cases, they often suggested that be done at a later stage in the design process, particularly the narrative. Nobody liked the titles. But here, a participant was discussing the use of a narrative as, again, sort of an evaluation metric for the client. Like, is this story being told? You've seen its trends in these data, and now you can go on and better shape what that story looks like because you know what's happening. Most people saw title creation as a very, very late stage thing. They were like, we would not try doing this before our design was finished. So that seems to be more like data journalist nuance. So in return to our original research questions, we want to know if they use it and what it does. So we know that designers don't really use writing that frequently. Study 2, actually, it was less common than in study 1. And it's not a core part of how designers think about their process as a whole and how they think through those steps and those actions. But maybe it should be, right? This intervention is pretty lightweight, took less than 5 to 10 minutes at the longest. Most of the time, they were seen as pretty helpful. In particular, key questions and conclusions might help sort of guide this process a little bit more neutrally than narratives and titles, but they still have this great potential for aiding the design process. And writing and text in general are underutilized in visualization design. So this is great for me because that's what my PhD is in. And so there's awesome areas of future work also available for exploration here. We'll talk about some of those. We can focus on the impact of those rotors on the final design, right? We just looked at those first 10 minutes. That is not indicative of what that design might end up looking like and whether you get any difference in storytelling ability at the end of the process. So a great new study would be to use a typical experimental structure, make hypotheses, do some randomization, and evaluate some outcome of that design. I also mentioned earlier that writing rotors may be useful for teaching visualization. So a couple of our more experienced participants actually mentioned that they thought it would be particularly useful to novice designers to scaffold that process. And just to be clear, if IRB is in the room, we did not experiment on students, but we did introduce this in InfoViz and had students start out with it as part of their design process or redesign process. And it seemed to be well received. We didn't, again, do any randomization or collection of data or anything, but it does seem to actually help that understanding of what design choices look like. And lastly, can't not say this, right? LLMs and natural language interfaces are much more prevalent. So we could be able to use these kinds of outputs to help make those design decisions or to augment those. Given the state of current work on how LLMs can replicate good visualization decisions, I would say we have some ways to go, and I'm happy to send papers to people who are interested in that specific question. But broadly, they're not yet able to kind of replicate what people think are good design decisions, or what rather people, I mean, researchers think are good design decisions. But given some data, an LLM could prompt a designer with different questions they might ask or different conclusions that might be taken away, and in so doing, provide that writing rotor for them. That's the gist. Writing and language are underutilized tools in visualization design, and we should incorporate them more fully. And I'm happy to take questions, or you can read that paper.
Great, well, we're out of time. It's 6 o'clock. Thank you very much.
Thanks so much.